Welcome to the video, guys. My name is Pushpinder Gill, and this is going to be my email address where you can send me your valuable feedback. And I've been loving your feedback, guys. And if you think that Perfect Scores helped you, make sure that you throw us a like here at facebook.com/perfectscores and explore more about us at perfect-scores.com. Right? So keep watching this space for more and more. Right? So today I'm going to do probability of complex events. So this is the third video on probability. In the first video we did the basics of probability, which is very crucial that you watch that. In the second video I introduce how would you do the coin probability, and in the third video now we're going to further elaborate on that, and we're going to say how would you calculate probability of complex events, right? So before even starting that, let's understand what exactly is a complex event. Well, it's not like the name suggests, right? A complex event is something that it's not actually complex. It actually comprises of so many different simple events, right? So a complex event can be as simple as, let's suppose I'm tossing 3 coins, right? So I can even get 1 head and 2 tails, and I can even get 2 heads and 1 tails. So that, according to me, will be a complex event which comprises of 3 individual events, right? So which comprises of 3 individual events. So let's suppose I'm getting 2 heads and 1 tail. So this is a complex event and it has 3 individual events, which is a head, and a tail. So let's suppose I am giving the exam 4 times. So whatever the result is coming every time, these are my individual events, right? So why would I need to classify an event as a complex event? Well, understand this thing. If you watch the second probability video, probability of a complex event is equal to probability of the individual events multiplied into its arrangement, right? So probability of all the individual events into its arrangement. This is what is the importance of this is. So let's suppose I tell you I want 1 head and I want 1 tail, right? So what is the so this, according to me, is a complex event. What is the probability of getting a head? 1 by 2. What is the probability of getting a tail? 1 by 2. In how many ways can H and T arrange itself? 2 ways. It can be either HT or it can be either TH, right? So these are the 2 possible ways in which they can arrange themselves. That means the probability is actually 1 by 2, right? So even if you draw the sample space and try to get the probability of getting a head and a tail is equal to 1 by 2. So probability of a complex event is equal to probability of individual events into its arrangement, right? So I want to further elaborate on this arrangement part before I hit the questions. In how many ways can you arrange the word, let's say, in how many ways can you arrange the word RAT? That would be equivalent to, if you want to arrange the alphabet of the words, the characters, that can be arranged in 3 factorial ways, right? I can have RAT, I can have RTA, I can have ART, I can have ATR, I can have TAR, and I can have TRA. So these are 6 possible ways in which these alphabets can be arranged of RAT. So is the number of words into its factorial. But however, if I say in how many ways will you arrange RAAT, that would be 4 factorial divided by 2 factorial. Why this 2 factorial? Because this A is repeating 2 times. If I swap this A from to each other, the word would still be same. However, I have calculated that. So if there are n things, out of these n things are identical, these can be arranged in n factorial divided by r factorial ways. So these are the number of ways in which they can be arranged, right? So in case you want to further elaborate this concept, you can actually watch the permutation and combination second video. So you can watch the permutation and combination second video. Over there I have explained everything about this concept, but for this video you just need to know this concept here, right? Okay, so let's move forward. So now let's see this question. Now this question says that probability that Daniel will fail is 25%. What is the probability that Daniel will fail in at least 3 times in his 4 tests? right? So this is what the probability that it asks us to calculate. Now let's go ahead and calculate that. Now he wants to fail at least 3 times in 4 attempts. So he's gonna have 4 attempts, right? So probability of failing, probability of failing, probability of failing, and probability of passing is one of these combinations, and failing in all is one of the combinations, because the question asks that he wants to fail in at least 3 times in 4 tests. So he can fail in 3 tests, pass in 1 test, or he can actually fail in all the tests. Now the probability of failing is actually equal to 25%, which is 1 by 4, and probability of passing is equal to 3 by 4, which is 1 minus 1 by 4, right? So we have done that in the first video. So probability of failing is 1 by 4. Probability of failing, now this over here is a complex event. Now I am actually multiplying the probabilities of all the individual events. So 1 by 4 into 1 by 4 into 1 by 4 into probability of passing, which is equal to 3 by 4. Now what did I tell you about probability of complex events? It's equal to probability of individual events multiplied into its arrangement. Now in how many ways can this arrange itself? That would be 4 factorial divided by 3 factorial. Why 4 factorial? Because there are 4 numbers. Why 3 factorial? Because there are 3 f's repeating and they are identical. Plus probability of failing into probability of failing into probability of failing into probability of failing into 1, because the number of ways f can arrange itself, it's 1, or you can even say 4 factorial by 4 factorial, which is nothing but that one, right? So similarly you can just take 1 by 4 raised to the power 4 common. Now this is something that you can do every time you'll have something to take out common. So this and this is taken out, so I am left with a 12 here, right? And I'm left with a 1 here. That means my answer is 13 by 4 to the power 4, right? But this is not my job here. My job here, so that you understand this, that the complex event can be broken down into individual events, but you'll have to take care of all the possible arrangements. You know what? He can pass in the first exam, he can pass in the second exam, he can pass in the third exam, he can pass in the fourth exam. These are the 4 ways, which is actually given by 4 factorial by 3 factorial ways, right? So suppose you've understood this, let's move forward. Now let's see this question. This question says that a fair 2-sided coin is flipped 6 times. What is the probability that the result would be? Now the coin is actually flipped 6 times. So I will have 6 different results waiting for me, right? So a coin is actually flipped 6 times. Okay. Now the question is saying what is the probability that I will have at least, now the word at least is the key here, I will have at least 2 times tails, but maximum, right? But maximum 5 times tails, right? So this is what the question is saying, maximum 5 times tails. So I can even have 2 times tails and 3 times head, right? I can even have 3 times tails and 4 times head. I can even have, sorry, it's 2 times head, right? Okay, sorry, it's asking for 6 times. So I can have 2 times tails and I can have 4 times head. I can have 3 times tails and I can have 3 times head. I can have 4 times tails and I can have 2 times head. And I can have 5 times tails and I can have 1 times head. Now calculating this would be really tricky, isn't it? So either I can calculate it this way, or I can calculate it as 1 minus the probability of not getting 2 times tail and maximum getting 5 times tails. That would be probability of getting 1 time tail and getting 5 times head, and the probability of getting 6 times tails and the probability of getting 6 times head, right? So I'm just listing down all the possible cases. Either I get the question this way or I get the question this way. So if I do 1 minus probability, now you can clearly see 1 by 2, 1 by 2, 1 by 2 is going to be everywhere 6 times. It's clear, right? I will have 1 by 2 for 1 head and 1 by 2 individually for 5 heads. So that would be 1 by 2 raised to the power 6, that would be common to all. Now all I have to do is just think about arrangements. So how many ways can you arrange t and 5 times h? That would be 6 factorial divided by 5 factorial. This would be 6 factorial divided by 6 factorial, and this would be 6 factorial divided by 6 factorial. So this will come out to be 1 divided by 1 by 64, which is 2 to the power 6 into. So this is something which is equal to 6. This is 1 and this is actually 1. Right? So this is 6 plus 1, which is equal to 8. That is 8 by 64. Which is equivalent to 1 minus 1 by 8, which is equivalent to 7 by 8, which actually is my answer. So I'll give you a task. Try calculating this question this way. You will always get the answer to be 7 by 8, right? That will actually make sure, that will actually put that in your head that, you know what, I can calculate the question this way also and this way also, and every time this thing works. Probability of a complex event is equal to probability of all the individual events multiplied into its arrangement. Right? So that's what it's all about. I suppose everyone has understood this. A very easy question. Not that easy though, but still gotta be careful about everything. Now the question says that Danny tosses a fair coin 8 times. What is the probability that coin will land tail side up more than 5 times? So the coin is tossed 8 times. I want the tail side up more than 5 times. So I can have 6 times tails and I can have 2 times head, or I can have 7 times tails and I can have 1 time head, or I can have 8 times tails. Right? So what is the, now again 1 by 2 to the power 8 will be common to all, right? So I can actually take it to be common. Now if I calculate this, this is gonna be, the combination here is gonna be 8 factorial by 6 factorial into 2 factorial. Similarly over here it would be 8 factorial by 7 factorial, and it would be 1 here. So if I calculate this again, it's 1 by 256 into, so this is gonna cut this at 7 into 8, and this is gonna cut this at 4. So this would be 28 plus 8 plus 1, because this would be 8. So if I calculate this, what is 28 plus 9? That is gonna be equal to 37 divided by 256, which is actually my answer, which is answer option A. Right? So suppose you've understood this question. I'm not doing any magic here. What I'm simply following is, I'm writing this down. He wants more than 5 tails. Fine. He can get 6 tails and 2 heads. He can get 7 tails and 1 head. He can get 8 tails. And I just went on to calculate that. And understand, probability of a complex event is probability of individual events multiplied into its arrangement. Don't forget the arrangement. If you forget the arrangement, then your answer would always be straightforward. Right? So suppose you have understood this question. Let's move forward to the next one. Now this question says that David, Chelsea, Andrew, Maria and Danny are playing a board game in which card is drawn by a player. And the question says that 3/4 of the cards in the deck are marked with a circle. So the probability that I will have a circle card, it's 3 by 4, and 1/4 remaining cards are actually marked with a square. That means probability that it will be a square, that would be 1 by 4. Now the question is saying, if 5 players draw a card and then return it to the deck, what is the probability that at least 4 of the cards are marked with a square? So what different cases I have, what different complex events I have, right? So writing this as complex events. He wants at least 4 cards as a square. So he can have 4 cards as a square and 1 card as a circle, or he can have all 5 cards as a square. Right? Now again, it's all matter of me solving this question. Now again, S is coming 4 times. So 1 by 4 raised to the power 4 into circle is coming once, which is 3 by 4. Now I have to take care of the arrangement also. In how many ways can 4 S's and 1 C can arrange? It's 5 factorial by 4 factorial plus this is simple, which is 1 by 4 to the power 5, right? Which is actually pretty simple. Now what will I do is, I'll take 1 by 4 to the power 4 common outside. That means this over here is gonna give me a 5, right? I can even take 1 by 4 to the 5 common outside, because this 4 to the power 4 and this 4 will come. This will give me a 15 and this will actually give me a 1 because I'm taking 1 by whole 4 to the power 5 outside, and that would be 16 divided by 4 to the power 5, which is 1 by 4 to the power 3, which is my answer, option A. How much time it takes, guys? It hardly takes you a minute to solve this big question, right? So this is what I'm saying. This question can be very well on your GMAT or very well on your CAT. So all you have to be is just careful about every possible combination that you take. Now you can even say, you know what, I'm drawing 100 cards. Still you can do this question very easily, right? So again, just repeating it once again, the probability of a circle is 3 by 4, square is 1 by 4, and he wants at least 4 squares. So 4 squares, 1 circles, and 5 squares. So that's the way to go about it. So suppose you've understood this question, let's move forward to the next one, right? So now this is something that I want to emphasize here. Now this is very crucial, guys. Now I am actually explaining a concept here. Now the question says a ball contains 4 red ball, 4 green ball, and 4 white ball. 3 balls are picked up one by one. What is the probability that there will be at least 1 red ball? So if I want to calculate at least 1 red ball, that can be calculated as 1 minus not getting any red ball, right? So 1 minus not getting any red ball, that will give me the probability of getting at least 1 red ball. You can watch the first video on probability. Over there we have discussed what is at least 1. So at least 1, so 1 minus not getting any red ball means, and how many balls I'm drawing? I'm drawing 3 balls. That means I can draw any of these balls, right? So again, these are total 8 balls which are there, right? So this is 1 minus drawing any other ball, drawing any other ball, and drawing any other ball, right? So that would be 1 minus, in how many ways I can draw any other ball? That would be 8 by 12, because these are total of 8 other balls, and 7 by 11, and 6 by 10. And what is the arrangement here? The arrangement is just 1, because then according to the question, this is just other balls. According to the question doesn't know there are green balls or there are white balls. These are just other balls. So the other won't matter here at all. The segregation within it will not matter. That will make the question so easy for you that you won't even believe that. So 6 into 2 is there, right? And this goes at 4. This goes at 2, and this goes at 5. So this is 1 minus 7 into 2 is 14 divided by 55. So I have my answer as 41 by 55. Right? Now, I got my answer as 41 by 55 even by considering is at other. Now you know what? This other can very well be all 3 greens. It could very well be all 3 whites. It could very well be 1 green and 2 white. It could very well be 1 white and 2 green. How am I able to club all these these things into this? Well, I give you one small exercise. Right now, try to calculate 1 minus probability of getting all green, probability of getting all white, probability of getting 1 green, 1 white and 2 green, and probability of getting 1 green and 2 white. You will still get the same answer. Why is that? Because this other actually takes care every possibility here. So if according to the question it doesn't matter, the other doesn't matter at all. Right? So this is something that I want to be embedded inside your head, just the way we embed videos on website. That if I say other balls, right, and other balls can be, you know what, red balls also, white balls also, green balls also, it doesn't matter at all. According to the question, other is other, right? So you can actually take all the others as identical, right? So this is what I want to say. Okay, so suppose everyone has understood this. Now this is what I want to emphasize: the other doesn't matter at all. So if I have something as red other and other, the number of ways this can arrange is 3 factorial by 2 factorial. That's it. You don't have to worry about this other can have different variations, but according to the question is other and other. Right? So this is something that I want you to know. Let's actually try a tough question on that. Right? Now the question says that Daniel is playing. I would actually recommend you to pause this video and so that you can actually solve this question. Okay, so let's start. Daniel is playing a dice game in which a dice is rolled 5 times. If a number turns up exactly 3 times, then the game is won. Daniel has thrown the dice 2 times and got the number 4 2 times. What is the probability that Daniel will win the game? So how many ways? So what are the complex events, different ways in which he can actually win the game? He's already thrown it 2 times. He's already gotten a number 4. He is planning to throw it 3 more times. So how can he win the game? He can get 1 4 and 2 other numbers, right? Or he can get any number here, any other number here, but the next number to be the same and the next number to be the same. That is the way he is going to win. Elaborating more on that, he can win by a 4 1 and 2. He can win by a 4 1 and 3. He can also win by 1 1 1 and 2 2 2, because if he gets a number exactly 3 times, he wins the game. So 4 4 3 3 3 is actually a win. 4 4 5 5 5 is actually a win. So these are the 2 possible ways in which he can win this game. Right? So now let's go ahead and calculate that. What is the probability of getting a 4? 1 by 6. What is the probability of getting any other number apart from 4? 5 by 6. What is the probability of getting any other number apart from 4? 5 by 6. In how many ways can 4 other arrange itself? Very easy. 3 factorial by 2 factorial. Then I do a plus. In how many ways I can get any other number apart from 4? 5 by 6. In how many ways I should get the same number? 1 by 6. Same number? 1 by 6. And what is the arrangement here? It's 1. Why is that? Because 1 1 1 2 2 2 4 4 4 5 5 5 can arrange in only one way. So if I calculate that, that comes down to be equal to 75 plus 5, which is equal to 80 by 216, which is my answer here. So I suppose you're understanding the simplicity with which we are solving a question, and this is, if you talk about GMAT, this is a 51. This is a 97th percentile question, right? For the guys who don't know too much about GMAT, that in GMAT the maximum you get is 97th percentile. The maximum score is 51 right now as per 2013, right? So you can very well see here that with such simplicity we're solving a question. So I'm going to rewind it once again. Now he were to actually, to win the game, he were to get a number exactly 3 times. He has already gotten 2 times 4. So if he gets 1 4 and 2 other numbers, he wins the game. If he gets all 3 numbers as different numbers, as the same numbers apart from 4, he wins the game. Understand, 4 4 4 4 4 is not a win, because he has to get a number exactly 3 times. And from there, when we got this, we just calculated it and we got our answer. Right? So suppose you've understood this one. Alright, so let's go ahead to the next question. Okay, let's go and do this question. Now this question says that 3 integers from 1 to 100 are randomly selected such that one integer can be selected multiple times. What is the probability that the sum of 3 integers will be even? Right? Now again, the sum of 3 integers should be even. So how do you get sum of 3 integers to be even? Either all 3 of them are even, or 2 of them are odd and the last one is even, right? So if you think about other possible cases, getting one even number, right? So getting one even number and getting 2 odd numbers, that would be wrong. So that is actually that same case only. Getting 2 even numbers and getting 1 odd number will actually give you an odd number, or getting all the 3 as odd numbers will also give you as odd number. So these are the only 2 possible cases which are true. So what is the probability of getting even? 1 by 2, 1 by 2, 1 by 2. So that is 1 by 2 raised to the power 3 into how many ways can this arrange itself? 1 way, plus 1 by 2, 1 by 2, 1 by 2, which is 1 by 2 raised to power 3 into how many ways can this arrange itself? That is equivalent to 3 factorial by 2 factorial, right? So now it's easy. It's 1 by 8 plus 1 by 8 into 3, so this actually goes at 3, so this goes down to 4 by 8, which is equivalent to 1 by 2, which is my answer. Right? So suppose everyone has understood this. See the simplicity with which we are solving. That is what I want. And when it comes to GMAT, these kind of questions are always hard level questions. So you can clearly see that solving the hard level questions in GMAT doesn't take that effort. It actually takes a right technique at the right time. Right? Okay, so thank you very much for watching the video. Right? So these are the 3 pillars. First is you give me feedback at perfectscores89@gmail.com. Like us if you think that Perfect Score is helping you, facebook.com/perfect scores, and explore more about us at perfect-scores.com. Right, so this is it. I suppose Perfect Scores has been helping and will always help all the GMAT, CAT, and SAT GRE aspirants, so all the standardized testing aspirants. Thank you very much, guys, and I'll see you in the next video.